EMF of a cell means electromotive force. In a cell, the EMF is the energy which is used to transfer charge in a particular circuit. That means this EMF will be the total work done in transferring the charge in a circuit from this positive terminal to the negative terminal battery. So here the potential difference V will be equal to E minus IR. So we can define, in other words, electromotive force or EMF of a cell, that this V will be equals to E if I equals to 0. So if I is equal to 0, that means V is equal to E. Means EMF is the potential difference between the two terminals of the cell when no current is drawn from the cell or the battery. In other words, we can say the EMF of a cell is the potential difference between its two terminals when the cell is in open circuit. Means when the cell will be in open circuit, there is no connection, that means no current is drawn from it. One way is this. The other way, if R equal to 0, that means 0 internal resistance is there, then still V equal to E. But this is an ideal condition. Every cell has some internal resistance. So this is the correct to say. Now, if we plot the graph between V and I, then the graph comes like this. So when no current is drawn, the V is maximum, that is E, as it is very clear from here. Similarly, when the V is 0, that time the current will be the maximum. When the V is 0, then that time current in the circuit will be maximum. So this I that time is E upon R, or you can say the internal resistance of the cell will be E upon this I. So from this graph we can find the internal resistance of this graph, that is nothing but slope of this VI graph. So if we find out the slope of this graph, that will be the internal resistance of the concerned cell. Once again, I'll repeat it. Electromotive force is the force or the work done in transferring a charge, that means unit charge, from one terminal of the battery or cell to the another terminal through the circuit. So that means E equals to W by K. That is the also definition of the potential difference also. So here V equals to E minus IR. If suppose you connect this cell with this R and then a resistance capital R over here, so this will be the V. That V will be equal to I into R. So this V will be equals to E minus IR, because here it will be E will be equals to IR plus I into R. So E minus IR will be equal to IR, that is equal to V. So this V is E minus IR. So when this I will be 0, that means no current is drawn from the cell is an open circuit, that time the V, the potential difference between the two terminals of the battery will be the EMF. If we plot the graph between V and I, then we will get the graph like this. And it is very clear from here, when I is 0, when I is 0, that time the V is equal to E, which is very clear over here by the definition of the EMF. Now, on the other hand, when V is 0, then I is maximum that time, means when the V will be 0, so maximum current will be drawn from the cell, and that will be equal to I equals to E by R. So we can find out the internal resistance of the cell is equal to E by I, which is nothing but the slope of this VI graph.